Today we're going to talk about the concentration of chemicals and how we measure concentration in different ways using different units of measurement. We use various units of measurement when we talk about concentration depending on the context. A common one is the weight per unit volume notation that usually uses the unit grams per liter. This is useful because it's the simplest way when we are mixing a known mass of a solute into a known volume of a solvent. For example, when I mix or dissolve 17.5 grams of sodium chloride or table salt in half a liter or 0.500 liters of water, and I ask, what is the concentration of this salt water? To calculate that, you would take the number of grams of your salt and divide it by the total volume, which is 0.500 liters of your solvent. When you plug that into your calculator, you'll see that this is equal to 35.0 grams per liter. This just so happens to be the approximate concentration of seawater or salt water. Now, another example of a unit we report concentration in is particularly useful when we use stoichiometry to measure the concentration of various products in a chemical reaction. And this unit is referred to as molarity or moles per liter. It's fairly simple to obtain when you know or have already calculated your grams per liter concentration, because it simply uses the concept of the molar mass. We know from looking at a periodic table that the molar mass of sodium chloride is equal to 58.44 with the unit grams per mole. Now, if I simply take my calculation of 35.0 grams per liter and multiply this by our, in this case, 58.44 grams per mole, when we line up our units this way, we know we can cancel out our grams on top like this, and we are left with essentially dividing 35 by 58.44, which happens to equal 0.60 moles per liter. That's how you calculate molar concentration.